Many people that try to solve this equation will probably get stuck. Why? Because they'll be deceived by this x squared. They believe that by taking the root of both sides, they'll definitely get the answer. But no, this does not work that way. Why? Because this is a transcendental equation, so it doesn't work. How are we going to solve this? The best way to solve this is by pure algebraic manipulation. Yes, and whenever we see this kind of question in our exam, what we should try to do is that we should try to isolate the variables and also the constants, the numbers. So what I mean is that we try to take x to the other side, bring them together to unite them. We also try to unite the numbers, right? So we can have the letters on one side and the numbers at the other side. So then how can we do this mathematically? The way we can do this mathematically is by dividing the power of both sides by x, first of all. And why can we do that mathematically? Because of course x cannot be equal to 0. If we have 0 squared, it's not the same thing as having 16 raised to the power 0 here. Therefore, we can safely do that to avoid extraneous solutions. So dividing the power of both sides by x, we're going to have x to the power of 2 over x equals 16 to the power of x over x. Therefore, x cancels x. So we'll be left with x to the power of 2 over x equals 16. Right? That's the first step. Now, the second step is that we need to move 2 to the other side of the equation. And how do we do that? Same step, by dividing the power of both sides by 2. So we're going to have x to the power of 2 over x, then multiply the denominator by 2, equals to 16 to the power of 1 over 2, because we can say 16 have the power of 1. Therefore, we're going to cancel out 2. 2 cancels 2. We will now be left with x to the power of 1 over x equals 16 to the power of 1 over 2. Very good. We can simplify this number here because 16 to the power of 1 over 2 is the same thing as square root of 16. Therefore, which will give us 4. So we have x to the power of 1 over x equals 4. Now, this is the big equation. What do we do from here? This is where many people will likely get stuck, because we have x to the power of 1 over x equals 4. How do we move further from here? Now, the smartest way to solve transcendental equations like this is by trying to create uniformity between the structure of the variable and that of the number. What that means is that we have to try to express this number in form of this variable. This variable, we have x to the power of 1 over x. Here we have just a single number. Therefore, we have to rewrite 4 as 2 to the power of 2 to begin with. Rewriting this, we are going to have 2 to the power of 2. Then x to the power of 1 over x equals 2 to the power of 2. We are not done yet. Why? Because looking at the structure at the left hand side, the power is a fraction, but here the power is whole. Hence, we need the power here to also be a fraction. How do we achieve this? By algebraic manipulation. It means we have to rewrite 2 as a fraction mathematically. And how can we achieve that mathematically? Is by using a brilliant manipulation. And what's that manipulation? Now listen carefully. We can rewrite 2 as 1 over 2 all to the power of negative 1. Yes, mathematically this is valid. Why? Because 1 over 2 is the same thing as having 2 raised to the power minus 1. And at the end of the day, 2 raised to the power minus 1 multiplies minus 1. I'm going to have 2 raised to the power 1, which is the same thing as 2. Therefore, 2 can be written as 1 over 2 to the power of negative 1. That's a very smart move that we're going to employ. Therefore, we write this equation here as x to the power of 1 over x equals 2 to the power of 1 over 2 to the power of minus 1. Now, what have we done? We have actually made the equation look a lot messier. Why? Because we have introduced negative 1 here, and here doesn't have negative 1. What do? It means what we have done here is not actually helpful because it has made the equation look a lot messier. I know about this before, but I had to go through this first so that you can understand the idea behind having a uniform structure. Now, because you can't actually go this way, But we can also go another smart way. What's that smart way? Since expressing this power as a fraction will make it messy, we can actually express this base as a fraction. Yes, so that this will just be the inverse of this. We can do it that way. Therefore, it means we'll have x to the power of 1 over x equals, instead of 2, we express 2 as 1 over 2 to the power of minus 1 or to the power of 2. Yes, now instead of us converting the power, we have now converted the base to a fraction. Therefore, we can rewrite this as x to the power of 1 over x equals 1 over 2 to the power of minus 2. Yes. Though we are getting very close, but we are not done yet. Why? Because don't forget, the structures must exactly be the same. But here now, there's a problem with the structure. What is the problem? The power here is negative, but the number here is not, the base here is not negative, because at the left hand side, the base is positive and the power is positive. They have the same sign. Therefore, at the right hand side too, they must have the same sign, exactly the same sign. It means we have to introduce minus to the base. And there's something very interesting. We can actually and arbitrarily introduce minus to this base without fearing any consequence. Yes, it is mathematically valid. Why? Because of the property of square. Don't forget, mathematically you can have 2 square is to be equal to minus 2 square, because square has the property of cancelling out minus. So 2 square is the same thing as minus 2 square. That's 4 equals 4. It means we can safely introduce this minus here. In case you are still confused, we can rewrite this as minus 1 over 2. The negative power becomes a fraction, then 1 over, then raised to power 2. So you can see that these two here will cancel out the minus. Therefore, we haven't done anything mathematically wrong. That's another brilliant idea we're going to be using here. And please, if you are learning from this, don't forget to subscribe as a way of supporting and also a way of learning more mathematical brilliance. Therefore, we have x to the power of 1 over x equals minus 1 over 2 all to the power of minus 2. We will actually prefer us to write this minus at the denominator. So it will be 1 over minus 2. So I want this to be exactly the same. It doesn't mean, right, mathematically. Therefore, we can see that this equation is looking very much like this. In fact, they're almost the same thing. For us to clear our doubts, let us just use a simple substitution. Let's just say, let 1 over x equals y. Then therefore, x will be equals to 1 over y. So let's rewrite this. It means s, we have 1 over y, all to the power of 1 over x is what? Y, equals to 1 over minus 2 all over minus 2. Now, if you observe this, you see that this equation is exactly the same. We have a base and the power that are exactly the same. Therefore, we can conclusively say that y equals minus 2 by direct comparison. And don't forget, y equals 1 over x. So we have 1 over x equals minus 2. Therefore, we can now solve for x here directly. We have x to be equals to minus 1 over 2. Correct and brilliant. Now, if you know you learned something from this equation, don't forget to subscribe so you can learn more and check out some of my videos that include more intricate and interesting algebraic manipulations that we can learn. Till next time, have a good day.